Okay, everybody. This is the last keynote of this EuroPython. So let's welcome Mike Müller and his Python paradox.
Thank you very much. Good afternoon, everybody. I would like to tell a little bit about the Python paradox. And people ask me several places already what that paradox means, but the subtitle tells you a little bit more maybe. How can a programming language be equally appealing to beginners and advanced programmers? So that's a question I'm asking here, and I think I can partially answer, but I also would like you to engage in the discussion about it. First, setting the stage, I need to talk a bit about me, not only to show off, but give you a little bit background why I have this talk. So I have a scientific background myself, being in research for a while and also in consulting, with scientific connections. And I use Python since 1999. The version 1.52 was brand new at this time. So I saw Python evolve. So that's a little bit, this talk is based on my experience with Python, how Python changed over time. And I do Python training for 9 years now. And the Python Academy as a company existed in 2006. So where I intensified the training. And I also involved in a lot of community things. So I'm involved in a lot of conferences. I either initiator or organizer. So I'm heavily involved in EuroSciPy, PyCon.de, and EuroPython next year, as you might have heard yesterday. And I'm a PSF member, and also I'm in the Python Software Verband, is a German kind of PSF equivalent, more or less, chair. So I'm involved in the community. So why this talk? I run a lot of trainings, and during these trainings, I have a contact with a lot of people, a lot of different people. So very, very different types of participants on these courses. So at one end of the spectrum, you have those people that are professional software developers. They have 10 years C++ under their belt, or Java, or something like this. So they're very versed, and they know pretty much everything. So if you're really sophisticated and you can write C++ fluently, then you have been there for a while. And we have sysadmins in there, so people that not really programmers, but they do administration tasks, DevOps, sysadmins, those kind of people. Folks with some programming knowledge, they know some programming, but they're not really software engineers. A lot of scientists fall in this category, so they do probably Fortran or Pascal or some C, and they program how much they need to get their things done, but they never do really so many software engineering things. And we have total beginners. Now, this group is growing now, so people that never programmed before get into programming for various reasons. And this is the people I teach usually. And all seem to get along learning Python, and many really like it. There's always maybe a few people that have to go to the course. They're kind of hesitant at the beginning, but many really like it. So I have examples that people during the course implemented prototypes of pretty sophisticated applications that would take them much longer, weeks or months doing in C++. They learned Python, and during the course they programmed applications, which is amazing, I would say. And so pretty much everything gets something out of it. So now, how does it work? How can people that never programmed before use the same programming language as people that have a lot of experience and get something out of it and it works for them? That's the question. That is the basis for this talk. Just who uses Python? Seems like everybody uses Python. I'm preaching to the choir here. I think you know this. So software engineers use Python. Scientists and engineers, this group. Financial sector is using it. Kids use it as a first programming language. More and more is used in schools. We know this. So it's embedded for scripting. The Raspberry Pi is a very nice example that's used. And many more usages you can list. So it's a very wide field. That's also how can this be that it works? I think there are several groups or categories of reasons. First is a technical. So that's I think the reason we are most familiar with, because we are technical people. So there are technical reasons for this. It's very easy to get started. It's very important. If a Linux system, you just type Python and there you go. On Windows, it's also not too bad. You just have to download something, double click, and install something, and you can start. That's important. Then you know about this shallow learning curve. So, but it means you don't have to learn void static main to get a print out on the screen. You just can get started easily. That's very important for a lot of people that fall in this category that don't know much about programming. It's very easy to get started, and with a little knowledge, you can get something done already. That's very important. So we have early success. It doesn't take you days and days and days until you get something done. Then it's very great, but now you can go step by step. That's important, I would say. And the syntax, we know about indentation stuff and like this, so it's very understandable syntax, so execute with pseudocode part. That's the technical ones. We have only a few data types, so the limitation is a good thing here, so we don't have many different kinds of integers and floats and stuff going on, only one data type, which is important for beginners. And I would say partial knowledge is really useful. Sometimes I'm amazed people that don't know much about Python and they change some scripts and it works and they're satisfied. And I think one reason is the multi-paradigm thing. So you can use object orientation, but you can also use just normal procedural programming if you want. You can use some functional features. Depends where you come from. So that helps in this regard. So very easy. Everybody knows interactive prompt is important. You can start interactive prompt. You can use it as a pocket calculator. So I do this often, and that's something very useful. This interactive prompt, especially in teaching, I spend most of the time at the interactive prompt because I type one line, I see the result. People can do the same, and hopefully see the same result. And this is a very good thing because you have immediate feedback. That's very important for learning. So if the feedback loop is too long because you have to wait for compilation and then there's a compilation error syntax, so that it's much easier to do interactive. That's the simple usage kind of thing. Another simple usage, there's a lot of libraries. So Matplotlib, a lot of people mention it here. It's one of those that comes from the scientific area. And Matplotlib, you can read it, work with objects and do instances, but you can also work with this very simple one. Actually, the very first line would be enough to plot something, and the other 3 lines are just adding some labels here. And if I do this, you end up with a graph like this. So with one line, actually, more or less, you can just have 100 random numbers plotted there. And that's very important for people. If you want something quick, you have some very reasonable defaults, something comes out, and there you go. So that's pretty much most of you will know this. But also you can do a lot of advanced things. In the morning I gave a talk about meta-programming. You have meta classes. So if you want to, you can get much deeper in the language. So but you don't have to. So I teach courses where I have meta classes inside, and a lot of people, they use Python for years, many years, and never had contact with this meta-programming, or not, at least they didn't do it themselves, meta-programming. They might have used it, consumed it, but they haven't produced anything. And they're pretty happy with it so far, but now they're more curious to learn about. So these things are there, those advanced features, but you don't have to use them. This comes in levels. I think that's important. For Python, you can write domain-specific languages and other things. So there can be a lot of advanced Python usages here, and you can do things at this level. I would like to show you one example. Decorators, it came up in other places, so I can make it short. Just the principle, the differences between writing a decorator and using a decorator. So writing can be very involved, but using a decorator is simple. So if you write a parameterized decorator, so decorator has a parameter, looks something like this. So pretty much a decorator is just a function that returns a function that returns a function. So this is not too difficult. So it takes a function, returns a function. So I write a decorator. I use functools here. And this how it looks like. So you write a function that takes the arguments here. This is I told argtimes. It's a decorator to check the arguments of a function when you call it, the argument types. And you have this 3-level approach. Very outside, you have this decorator I call check that takes archetypes. The star means it takes any kind of positional arguments. Inside, you have another function. Very often, you see this just using underscore. You don't invent another name, which takes a function to be decorated. And then inside, there is a function that's going to replace this function, func there. And you use this functools reps to make it nice. That's pretty much the skeleton of this parameterized decorator. And then you have to put the flash in here, where the 3 dots are, to make it do something useful. But more or less, it looks like this. And if you do this, then that would be something. Here I'm checking a few things. I check that the number of arguments I really get It's the same as a number of arguments I specified that are allowed. If this is not the case, I throw an exception. The same thing, I go through all the arguments and argument types here with zip and check that these arguments I get are it's an instance of this one. That's the checking of this, and if this is not the case, I also throw an exception. So this can get a bit involved, and this is something. It takes you a while to write those things and go through that. It really works, and also you catch some corner cases, things like this. So that's a really involved programming. But then, if it comes to using, it's easy. So if using it, it's very easy. You just say check, and you say I want this function add take only 2 integers, and then it takes only 2 integers. So that's a principle of Python. The usage is very easy, very intuitive, pretty much. But the implementation can be really involved. That we see in many places, and that's one of those technical reasons that makes this language suitable for this different kind of groups of users. So not that simple to implement, but really to use. That's some technical reasons I see. Other reasons are you might call social reasons. So Python has a very, very nice community, as you might know. I think it's a quote. I'm not really sure whom to contribute it to. I think it's just Müller. You come for the features, but you stay for the community. That's true. A lot of people like the Python community and has something special about it. You might have experienced, and this is very important also. If you go to Stack Overflow and you ask the Python question, I've been there for a while and watched it. It takes literally 1, 2, 3 minutes. If a simple question, you get 2, 3 answers to this question. So that's a very fast response time, I have to say. So there's a lot of questions about dictionaries and lists and stuff like this. So those simple things where beginners fight with data structures, and there are a lot of very good answers, very Pythonic answers how to do things very quickly. And of course, if the question is a little bit more special, it takes a little bit longer, but still you get answers. Just one example. There are many other places. So if you need help about Python, you will get it many places. It's very nice. So that's also how the community works. That's amazing. So there's lots of online resources for Python things. If you look it up, you will find many, many, many things. So that's very important that people get help. And yeah. So, and of course, we have great Python conferences, as you can see here. That's important. So I go to 5 or more conferences every year, and all of them are amazing. And you meet a lot of very interesting people and always learn something, a lot of new things. So that's important to have this community. And this community, so far I've seen, it's pretty open to new people. So we encourage people that never programmed before to give talks. At least, like I can speak as a PyCon.de organizer. We do this even if your Python foo is not that good, but you have very interesting application, please give a talk. And people recognize this. They say, see, programming the source is maybe not really perfect. It could be improved, but he's doing very well. She's doing very interesting things, and that's important. The community is very open for this, and it helps for people to get started. So that's another reason. So the technical reason, the social reason, and another one that's not that easy to pin down like the technical one. It's a philosophical reason. So Python has something written between the lines. That's not right there, but between the lines. The Python sen, we saw this in other keynotes. I don't want to repeat everything here, but the Python sen is very important. So we have some principle how to approach things, and Python sen is one of these. So if you say import this, you get some very nice poem about how to work with Python. Python fits your brain is another famous saying. It's also a quote. I think it's Michael. I'm not sure who said it. At least it's not from me. It's just it should be in quotes actually. So Python fits your brain. It's also something that it really has a very little overhead to solve problems, but it's also like a philosophical thing, more or less, if you want to put it in this category. And of course, it's open source. So that's we don't really talk about it much, but open source is very important, and it's also community-driven. So the development is really open source. There's no big company behind it that's kind of owning anything. Everything's open source. That's important also for this thing. That helps to people to get started because it makes it easier to be used in universities and places like this. So So far, everything is positive, but it would be boring if you just repeat the same thing. Everything is nice and positive. So I want to raise a few questions. I don't have all the answers, so yeah. But maybe we have a discussion. We can talk about it. There was a recent discussion at LinkedIn, a Python group. So LinkedIn Python group is pretty active. There's people discussing. I'm monitoring a little bit. And the question is, does Python have some kind of an image problem? Because we have this label like, is it scripting or glue language, which makes it like it's like useful for example, throw away things, gluing things together, throw things away. But as we know, Python is a fully grown programming language. But a lot of people from outside that don't know much about Python might perceive, see, it's just some scripting language. So what maybe say this, it's just like Perl. Perl is also a full programming language, but the way Perl is used is more like gluing things together. You don't usually use it for bigger programs, but Python you can. And it's just now the question, do we need this, what I call interfaces and enterprise-level features? Because we have this language that is very nice for beginners, but you don't want to put interfaces on beginners. All those features that can be useful for bigger applications might not be the best features for beginning users. And that's it's not a. It's just something. Because this image problem might be there, and people might be tempted to make Python more, what I say, enterprise level. That's just a question, and just a question: if we do this, would it be more accepted in business? It is accepted. We have a lot of sponsors here, but it could be accepted more. There's a lot of places people don't know about Python. They don't want to use it. They want to do Java or other things. And if you put enterprise level things into the languages, would help or not? That is a question. Oh, sorry, I haven't recompiled it here. Sorry. I have still some typos. Okay. And can we do this without losing the other side of the spectrum? So we have the two different sides of the spectrum. We have this beginning programmers, and we have this very advanced people here that do this. I think I need to disconnect a second and recompile it, because I've forgotten something. Just doesn't take long. So this is a question I would like to ask, and I will be back in a second. And maybe, of course, it's just, it shouldn't happen, but it happened. Doesn't take long. And okay. No, it's fine. It does take a second. That's okay. Good. Yes, put it back. Yeah. Okay. Now. Okay. So can we do this with losing this beginners? So if you put something in and make the language even have more features, which is nice, do we lose? This is one question, so keep it for now. Okay, and this is a question: do we have feature creep? This is something because since I'm using Python so for a long time, Python tends to gain features over time. So it's a very nice thing. So you cannot really lose features. Once the features are in the language, you cannot lose them anymore because people use them. The notable exception is Python 3. So in Python 3, you got rid of a few old deprecated things, but everything that's in Python 3 will stay there for a long time because until Python 4, probably it will take a while. So there's a small danger. So I don't want to spoil the celebration here, but it's just to raise some questions that they have a feature creep. You get more and more features because features are nice. But the fact is, the language grows. You get more features, the language is getting bigger over time. And the question is here, do we lose a small language? Python has this biname to being a small language that you keep in your head. But once you keep growing, adding more features, obviously language is getting bigger. So that's another question. If you lose this, and if it's bigger and more features are used, it will be more difficult for beginners to get into the language. So about this features, I still remember a feature called list comprehensions, which came into Python 2.2 or something. And there's always discussions on this about it. The first discussion, a lot of people reacted like this. Who needs this? And we have loops. We don't need it. Why do you need to have loops? And then later, this is kind of strange, but it really works. It's kind of strange. You have to get used to it, but it works pretty well. And then that's the best thing that ever happened. A lot of people have these reactions. List comprehensions are very nice to use, and I use it all the time. Once you're over this first difficulty using it, it's a very nice thing. So list comprehension come from Haskell, so they have some functional feeling to it. If you have a procedural background, it might take you a while to get used to this way of thinking. So that's how features come in. So features are nice and helpful. Do we like features? That's one thing. But on the other hand, they make the language grow. So if you want to keep a small language, you want features is somehow contradictory. That's something. So again, I don't have the full solution here. It's just it's my experience with teaching courses. My course material getting bigger and bigger. I have more and more pages of my handouts. I started with like 60 pages. Now the handout is about 120 pages about the beginner Python course, because I feel I like putting more things in because the language grows. So yeah, that's it. That's how it is. And yeah, and I don't have a real full solution, but maybe we can discuss a little bit about it. One solution would be to putting more things in the standard library. Python has a very good standard library, and it might help to put features in the standard library and make the features more optional, and don't put it in the language. That could be a solution. It's done already, so it's nothing new. So the collections module is a very nice example. So the collections module offers you very nice data structures, order dictants, things like this. And it's not part of the core language. Like sets became slowly part of the core language, but it's in a module in the standard library. So it's different. Iter tools is another one. You have very nice iter tools. A lot of the iter tools in Python 3, you don't need them anymore because they are part of the language, which is a good thing. But iterators are a bit harder to explain to beginners than just lists. So it comes with the price is very nice, but to explain things, then you have the strange iterator, and then you always convert it to a list. Is an extra step. And there's more. So this would be one way, putting things in the standard library, I see, and it's done already. So, and then what I explained at the beginning, easy use but sophisticated implementation. Context managers is very easy to use. You just stay with something, but implementation can be a bit more involved. Decorators, I showed, meta classes, and others. One example, Holger Kraker gave another keynote. He's the author of PieTest. And PieTest is a very nice tool. It's very easy to use. You just have a directory called tests. You have a module called test underscore. You have a function called test underscore. And then off you go, and it's doing things. And you just use assert. So it's very easy to use. And it's pretty understandable. But you can do very fancy things with it if you like to. You can do very fancy tasks, solve complex problems. And that's what I call Pythonic. So it's pretty easy to use, but it's doing a lot of fancy things behind the curtain, but the user doesn't really see this. So the implementation is involved because it's just re-implementing the assert statement and doing a lot of things. So this plain assert looks so innocent, but it's doing a lot of things. But you do, as a user, you don't have to. So we are there already, but we have to just to hide this complexity from the user. But if the user wants to dive deeper, can dive deeper in. So of course, this is modifying the abstract syntax tree, which is not something you do every day, I guess. And it takes a lot of expertise to do this right, because you might do some damage if you do it wrong. One nice example, I would say, and a Pythonic one. A killer app, one killer app would be the IPython notebook. IPython notebook. And I just prepared a simple IPython notebook. It was shown in other keynotes, and here I have an example. So this is IPython. If you start the command line with IPython notebook, it starts a local server, and you run it in your server. And it supports Markdown. It is just a Markdown cell. If you go here, it's just normal Markdown. And you see the HTML. Maybe you saw it here. This is a HTML cell, and if I leave it, if I just show you as it would be code, then it's just this very famous blink tag, just to show you this, and you can do something. And that's Markdown. You can use everything that's Markdown, and if you change this one to Markdown, since HTML is valid Markdown, you have HTML. And then you can write normal Python functions in here and execute them. And that's used a lot. If you go to the scientific Python conferences, all the tutorials are given with IPython notebooks. And that's a very nice thing because it's a mixture between documentation, text, executable code. You can put figures in there, you generate figures, matplotlib figures, include them directly. And that's a very nice thing. Those killer apps are very important and make things easier. So instead of going between the interpreter, the interactive prompt, and another tool, and in the shell, you can do everything in one. And you can even save those things as a JSON document, and you can exchange it. And there are a lot of online collaboration things nowadays. You can save this as a static HTML if you like to, but also keep it interactive. So that's something very nice. I would say that's one of those killer apps in Python. Yeah, good. So that would be one thing. And I had this idea because if sometimes people would like to add more features, and then you would end up with a kind of a Python ++, and I would like to avoid this. I don't see it, so it's just a feeling that, of course, you keep adding features over time, and it's getting more, and there might be a danger that it's getting too many, and you're losing these people. The people that are very experienced in program, they will like it very much, but people that are not. So we have this should be commit. So right now we have this benevolent dictator for life model, and I think that works pretty well, amazingly well. And we should keep this one to avoid a Python ++ that keeps keeping features just because it's a compromise between different people. So my opinion is we should limit the features in the core language, even though features are very nice and we like features, but if you keep the language small, it makes it easier to use for other people. So less is more in this regard. And improving the standard library can be one way can go. So where should Python go? I would define Python as a multi-level user language. So you have different levels of users that can equally well work with a language. And that's a kind of a unique feature. A lot of other languages are not like this. They're either like simple beginner languages or more sophisticated language you have to put more effort in. And Python is pretty unique in this regard. And I would like to keep this, serving different kinds of users, and it seems like it's possible. We are pretty much on the right track. There might be a few things that if things going slowly over time, you might not see, because you're too close to this thing when Python evolves. And when I communicate with new users that are new to the language, you see it sometimes they're struggling with things that is very common to you, though that can be an indication. So we have been done pretty well so far. And the question is now, how can we keep this nice small language that fits in your head, and at the same time expand to more users that want to use Python. So that's maybe the question I want to ask. Maybe there's an answer, and I would like to come into communication with you. Thank you very much.
Hi, two things. One is the matplotlib example. I think it has a typo at the very start of your presentation. Can you rewind there?
I executed it. It should work.
Mm. Yeah, very early in your presentation, you had two call to X labels and none to Y labels.
Yeah, maybe. Yeah, could be. Yeah, where is it? Doesn't go down? No, nothing works anymore. Okay. Was this if we have this slides things? Maybe I have some of here. I don't remember which slide it was. Because it's a lot of single slides. Okay, yeah.
There you go.
Yeah, it should be Y. Thank you very much. Yeah, there should be Y label, not the X label.
Yeah, I don't know how this can work. Anyway, the substantial thing was what would adding interfaces add to abstract base classes, which are an obvious superset of what interfaces can do. You can do an ABC, which doesn't actually have any executable code, although it's a city constraint, but you can do it. So would calling something an interface, which is an ABC, forbidden to have code? What the added value?
This was just an example for adding more features that that people might like to call it enterprise level. So sometimes people say that's what this was not.
Adding features that are a subset of ones that are already in the standard library, just so we can use the name. Are you in marketing?
No, I said I want to avoid it. Sorry, that was my wrong, because there are some people ask for those things, you know, and then.
Okay, anybody else?
Hi, thanks for the talk. Okay, let's say Python doesn't survive and it kind of just stagnates or loses momentum. Which language are you most concerned about will take its place?
I don't know. If a new language that's coming up, it's very difficult to make predictions. I have no idea which language could this be. So depends. There's a lot of different languages for different fields. So JavaScript is used a lot for a lot of things. That could be one that taking over more share, and a lot of new languages coming up. I don't know. I don't see one that has all these features.
Anybody else? Oh.
This is about adding more things to the Python standard library. There was last year, I think, there was this saying that standard library is where the code goes to die. Once you put it in the standard library, you cannot change it anymore. You cannot even sometimes fix obvious bugs, like with the asynchronous thing, the asyncore. And I think that installing PI packages isn't really that hard anymore, especially with the new stuff that is happening with Python packaging. Yeah. So maybe just put it all in there.
Make this even another step. I just opposed to put it as a core feature in a language. The next step is standard library. The next step would be an external package which can change over time. So that might be even better for different things. So you can add those things in this library.
There was one more hand around there. Oh.
Well, before Python there was Perl, and Perl kind of had a market before, but Python maybe now has. And it has there's more than one way to do it. Yes. And I think that, in contrast to Zen, actually that was one thing that got a lot of people converted, because it was easy for beginners, because you could, whatever you thought, it was code, because English was Perl. But it was very difficult to read. And I think what most people like about Python is the readability and the Zen thing. Yeah. So there's one way which we as a group consider to be the right thing, and we kind of agree, and that makes it very easy to work with a larger base. I think that's one difference which explains the paradox, I think.
Yeah, I agree. That's one of the reasons I put that as Zen. It's very important that this paradox.
Just a comment about the standard library question, and I do agree with that. The release life cycle of standard library is quite long, and my opinion is that I'd prefer to have a standard Python installation pack for third-party packages, and some improvements on that instead of like trying to move as much as you can to the standard library as well.
Yeah, so this was more like sets. Sets are a data type now. It's a part of the core language. Used to be in our own module, like the collections module. If you would move everything into the standard library, like all of the in the core language, then you would have more data types. So now you have the collections modules, and you have all those data types in there, and you don't have too many data types, because most things you can do with lists and dictionaries and sets. And if you really need to, you can go to the collections module to import from there. That makes the language a bit smaller, because you have this everything in this extra step importing things, so, as opposed to have everything readily available. So that's and of course, if it's something new, you want something that evolves, then you don't put it in the standard library. That's right.
I won't accept more questions on standard library. There is an open space tomorrow. Okay.
I just wanted to point out that there are actually 4 more typos in your presentation, but I won't tell right now, maybe later. Thank you.
Okay, is it a safe question? Okay.
Just a small remark. The thing is that Python is easy to read and call it self-explicit. That's a term I'm using against all other languages, actually. That's my zen of Python.
Yeah.
Okay, anybody else? Okay, so thank you very much. So in some minutes, the prize